notes on. Okay. So what we do for today is Fermi-Dirac distribution. We'll try to see what is this one. Then we can do some problems using this and we can close. So Fermi Dirac is the scientist name. Dirac is the one actually who proposed electron can have the spin. Okay, this is completely quantum mechanical. Okay, Fermi is another scientist. So Fermi and Dirac. Dirac said electron can have spin. Fermi, you know the Fermi. Who is he? Okay. So what Fermi-Dirac distribution function gives is Fermi-Dirac distribution. This applies to electrons. Point number one. So in an atom we have electrons, and how the electrons are there? Go back to your knowledge. Electrons are there revolving around the nucleus in a specific orbit, right? Electron number one, it revolves around this orbit, and next electron is revolving in this orbit. Like that we have several orbits and several electrons. Need not to be one electron, another electron can be there, but only one condition is there. What is that? Pauli exclusion principle. What does it say? No two electrons can occupy same. This is not possible. Okay, you need to have this configuration. Okay, so 4 quantum numbers cannot be same. No two electrons can have the set of 4 quantum numbers, or else in specific you should have opposite spinning electrons. Okay, so the electrons are revolving in a specific orbit, which means now you can ask why this electron is only revolving here, why not here? This electron number 1, I'll give name E1 is revolving only in this specific orbit, why not there? Any guess? Yeah, because it has only this much energy. Simple answer. Okay, this guy has only this much energy E1, so it cannot go up. Similarly, these electrons who are revolving in this second orbit, they have only certain energy E2, other one has certain energy E3. So these orbits are nothing but, in another way, they are energy states or energy levels, specific energy levels. How many energy levels we have? How many we have? So many energy levels we have, starting with 0. Let us name it as E1, E2 and so on. Depends on how much energy electron can have. It has its own energy, and if you want to supply, you can supply and take the electron to somewhere else. So infinite number of energy states we can visualize. Okay. So E0 is the ground state or the starting energy level for anything. Then E1, E2, E3. So suppose this, take this electron E2 for our study. We are taking E2 electron. E2 is sitting in E2. I mean, this electron is sitting in the E2 energy level, right? So electron number 1 is here. Then E2 also has some electrons there. Here also, let us say, some more electrons are there. Depends. 3 can be there or 4 can be there, depending on what atom you are dealing with. Okay. Suppose if you take hydrogen, H11, only one electron is there in one energy level. Helium, 2 are there. Oxygen, if you take O8 configuration, you are writing. Okay. So in each orbit, 1s2, when you say in the s orbit, how many electrons are there? P orbit, 3 shells are there, how many electrons are there? So depending on your atom, you can decide where the electrons are going. That's the case. Now what is this guy's Fermi-Dirac says is, look, it is, lot of energy states are there, and suppose an electron is there, this electron wants to occupy some specific energy state, where can it be? It is like simply asking, somebody is entering the physics lab, now I am asking where you would like to sit, because you are finding 4 seats, where you want to sit, 4 seats. Or in a movie hall we have, you know, different seating arrangements depending on the price that we pay. A person having only 100 rupees, he don't have any amount, so he can sit in the specific designed row only. 100 rupees is equivalent to the energy. So the electron having 100 energy or some energy, energy is measured in electron volts, some energy it has, it can go and occupy that place only. So why these 2 electrons are here? Because they have the energy of this much level only. Okay. So if I want send these guys to somewhere else, 100 to, you go and sit in the balcony. If I say to that guy, I don't have money, the ticket is 150, what should I do? If I give 50 rupees, he can go. Yes. So external, that is not his capacity, you are providing from external. So the same thing, if you give external energy to this particular electron, it can also either go here, or you provide more, it can go here, you provide more, it can go here. Okay, possible. So when you have to supply energy either in the form of photon, or in the form of temperature, or in the form of chemical energy or electrical energy, you give what sort of energy? You give energy, it can go to higher energy state. It's like you cannot go to the 5th floor when you are weak unless I provide a lift. Okay. So naturally everybody wants to stay in their stable state. Unless you provide some energy, it cannot go to. Now what is Fermi-Dirac distribution is, this electron you want to fill in a specific place, these guys will talk about the probability. Probability is nothing but chance. What is the chance for this electron to go and occupy here? What is the chance for this electron to go and occupy here? They give the chance or the probability. What is the probability? So what is the probability that electron can go and occupy some specific energy level? So this is easy. What is the probability? Let me write here. The probability function, they gave one equation, f of e is nothing but the probability, or else sometimes we call this is as Fermi factor. Fermi factor. In the exam we will ask, what is Fermi factor? This is the Fermi factor. F of e is nothing but 1 by 1 plus e to the power e minus e f by kt. So this is the equation to know the probability. So here what are all there? The left hand side is the probability, right hand side we have exponential of e minus ef by kt. So what is ef? Ef is called Fermi energy. Fermi energy. I did not tell you what is Fermi energy. Okay, we will look into it. What is Fermi energy? E is the energy of a particular state. Okay. It is the energy of a given state, E1, E2, E3. K is capital K. What is it? Boltzmann constant. The value you know, Boltzmann constant, right? Then you have T. T is nothing but temperature. Mostly it is in the kelvins. Temperature in Kelvin. Right. So now everything you know except what is the Fermi energy. So let me talk about the Fermi energy. It is very simple concept. Fermi energy is nothing but, what I am asking is, see, I have so many energy levels. Why these many energy levels came? Conduction band. When you say conduction band, so many energy levels. Valency band, so many energy levels again. Okay, let me not talk about so many energy levels, why it came, but let us take. So this is E0, E1, E2, E3, like that it is going to E infinite. E infinite. Now what is Fermi energy is? Fermi energy is nothing but the highest occupied energy level, which means I take electrons and started filling in some atom. One going here, maybe two are going here, maybe two more are going there, like that. Okay, suppose three are going here. So number of electrons I am systematically filling. Going to E0, then E1, E2, E3. So highest occupied is still E3 only. After that, nothing is there. So it is a reference energy level. Let us call it is a reference. So what is the reference? Okay, what is the highest field up to here? Above that, anything is there? Any electrons are there? Energy states are there, but nobody is there. Okay. So we say that, okay, let us take a reference energy level like this and call it as EF, Fermi energy level. Nothing but it is the highest occupied energy level. So now I am asking, see, I am not providing any temperature, or else I am not providing any electrical energy, no chemical energy. I am not giving any energy to any electron. Okay. And I am asking, what is the probability, if I don't provide, that an electron can go and occupy any energy level above Fermi energy level? So what I am saying is, I am not providing temperature, but I am interested in energy level which is above Fermi. Look, interested above Fermi. Now I am asking, what is the probability, which means probability is nothing but f of e. What is the probability that an electron go and occupy above Fermi level? What is the probability? No confidence. What is the probability? You are not following. Here, let me repeat. Your all electrons are here. I am not providing any energy, but I am saying I want electron in this particular energy level. What is the probability? Can it go on its own? I am not giving any energy. Can it go on its own? It cannot go. Here, it cannot go. Here, it cannot go. So any energy level you take above EF, you take any energy level, you cannot take it. So we know that probability is by default 0. As long as t is equal to 0, k, and if you are interested E above EF, you know that the probability is 0. Established. Okay. This is the point number 1, condition number 1 or point number 1. Now point number 2. Very easy again. Still same condition. I am not providing any external energy in the form of temperature. Temperature gives the energy of kBT. I am heating means I am giving energy. E is equal to kBT. So when I say T is equal to 0, I am not giving that energy. Okay. And now I am interested in what is the probability of electron occupying energy level which is less than EF. So where I am interested, basically I am interested in these energy levels which are lesser than EF. What is the probability that an electron go and occupy? What is the probability? Can electron be there below EF? Can it be there or not? How sure you are? How much surety you have? It's 100%, it is there only. So f of E will be 1. 1 is nothing but 100%, no? So it is there only, f of e is nothing but 1. So this is the condition number 2. Okay. Now go back to the question number, the Fermi level question bank you open, go back to Fermi level question and read, we will solve that. 2 conditions over, now third condition we are, okay, let me do the third condition also, read it. Fermi level question is there, read. Read it.
What is Fermi factor? By assuming the Fermi factor expression, show that all temperature greater than 0 degree, probability of occupancy of Fermi level is 50%.
Now you can do that. What they are saying? What condition they are given? What is Fermi factor? This is Fermi factor. And what else they are asking?
Assuming Fermi factor expression, so probability of occupancy of Fermi level is 50%.
Conditions, Ra. Tell me the conditions. What conditions are given there?
Temperature.
Mention that temperature is
Greater than 0.
in the question. It is clear that T is greater than 0. Okay. So what they are saying? I supplied energy from outside to the electron, and now you read what are the rest of the conditions. T is greater than 0 and
Probability of occupancy 50%.
where? Are you looking below or above? Which energy state are you interested? Energy level is which energy level? So your E is EF. That's what you need to know. You are not interested above or below. What you are asking? EF. I want to look at EF. That's what. Okay. Now you have to apply this condition and show that what they are asking you to show. The probability is, probability means what? F of E. They are asking show that f of E is nothing but 50% means 1 by 2. Show it 1 by 2. Do it. You have the Fermi factor. I gave you the conditions. Substitute there. Show it is 1 by 2. Do it fast. Very, very important question. It's not taking. Substituted. Okay, let us substitute it. So f of E, we know the formula. Let us not disturb. F of E is nothing but 1 by 1 plus e to the power. What is your E? Condition 3. E is nothing but EF. So EF minus EF by KT. Nothing but 1 by 1 plus e to the power of 0. E to the power 0 is nothing but 1 by 2. Done. Very simple thing. F of E is nothing but 1 by 2. Here. Right. Don't take photos. That's a bad idea. Okay, very good then. Simple. Now, any problem you can do. Actually, let us do one problem. Then we can finish off. So, let me erase this completely. So, any problem is there in the question bank, or else I will give you my own problem.
Yes, sir. Probability of an electron occupying energy level at 0.0.
Before that, let me also tell you one important point. Where does the Fermi level lies? Usually, if you take intrinsic or pure semiconductor, we have conduction band and valency band like this. This is valency band, conduction band. Conduction band has conduction electrons, valency band has holes. Usually, the Fermi level lies exactly at the center for pure semiconductor, exactly at the center, EF. Valency band starts here, ends here. So up to here it is valency band, or else energy of valency band, something, some name. Then conduction band starts here, EC, EC and EV. This is also called EV. Okay. EV. But the Fermi level lies exactly center, which means EF, this is for intrinsic, or else we call pure semiconductor. For pure semiconductor, your Fermi level EF is EC plus EV by 2, because it is exactly lying in the center. But now you deal with the impure ones. Impure is nothing but extrinsic. It again has N type and P type, right? So for N type has more number of electrons or holes? More number of electrons, right? So electrons are there in which band? Conduction band or valency band? Conduction band has. So your Fermi level lies near to the conduction band. This is your conduction band, EC, starting from here and going up to here. Your Fermi level lies near to that. In the case of N type. In the case of P type, Fermi level lies near to the valency band. This is your Fermi level. Conduction band. Keep it in mind. Okay, this P type, that is N type. So sometimes they may ask you also, so where does the Fermi level lies in case of pure and impure semiconductors? Tell us with the examples or the diagrams. This is what you need to. Okay, very easy thing. If at all they ask, maybe 2 marks they can ask. I'll close it. And nothing is there, man. You can't remember, lazy fellow. Okay. Yeah. N type near the conduction, P type near valency, pure in between. That's all. Right. Now we'll go to the problem of Fermi level. Read in the question bank. Any problem is there? Read it.
Calculate the probability of an electron.
Okay. Calculate the.
Probability of an electron
Hmm.
occupying an energy level 0.02 electron volt above the Fermi level.
Probability of an electron
Occupying energy level
occupying energy level 0.02 electron volts above Fermi level, above Fermi level at 200 Kelvin. So this is our problem. How many of you are sure that you can do it after listening this? Don't jump into solve, solution part unless you understand. First try to understand anything. Read, calculate the probability, which means what you need to find out. Given data you have to write. Okay, let us write the given data before attempting to solve. Given data. So in the given data you need to find out f of e. Calculate the probability. So nothing but what is f of e. What is given? Read. 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 Electron occupying energy level over 0.02 eV above Fermi level. So what is given?
of E is equal to E minus U.
Imagine the diagram, then you will understand what is given. Energy is given, which means E is given, EF is given, E has series of energies. So many E's you have. Remember how many E's we have? All these are E's only. Okay? He is saying I have some electron. This electron supplied by this temperature T. T is given anyway. Simple things let us write first 200 K. Find out probability, but which energy? Ultimately you will ask, okay, this electron where it wants to go? Here, here, here. Okay, let me say that this is my Fermi level EF. You will also ask me usually where you are interested, which energy level are you interested? Read again carefully. Tell me. Ma? Answer 0. How? Hmm. Read the question carefully. You are all confused. Electron, you are interested, occupying which energy state? Occupying energy level 0.02 above Fermi level. So where is the Fermi level? If this is the Fermi level, which energy state you are interested? Above Fermi level. So if this is 0.02 from here, so the gap between these two is 0.02. That's the meaning, no? The gap they are saying. From here, how much gap they are saying? From Fermi level, above Fermi level, I have energy level. The gap they are mentioning 0.02. So from here to here, they say it is 0.02 eV. So you are basically interested in this energy level, that is E. So now tell me what is given. That is important. That is the heart of the problem. E minus Cf is given as 0.02 eV. If you are not careful enough to read, you think you are doing right, but you will ultimately lose marks and you will worry. Sometimes they will trick you, they will say below Fermi level, which means what is given? E minus negative. Energy becomes negative. Okay? So we will do one more problem, it will be get. Now substitute and do it. So how do we do? So once you write the data, substitute in the formula. What is the formula? F of E you want to know. We know that. We know the formula. F of E is nothing but 1 by, do it, everybody do it. 1 plus e to the power E minus EF by KT. Look guys, you have to write the formula. Don't substitute directly. Just because you have calculator, don't do it like this. F of E is nothing but 1 by 1 plus e to the power E minus EF is given 0.02 EV divided by K is Boltzmann constant is 1 point, K is nothing but 1 point into 10 to the power 20 unit. Unit is important, man. What unit you are talking? Here are not there. Unit is not there. What is the unit? Joule per Kelvin. Okay. So look here. You need to make sure that your energy and K are expressed in the same unit. Temperature should be in the K, big, kelvins. Here also it is kelvins, okay. Temperature is also in kelvins, fine. But what is the energy unit? EV. Is it in joules? Because you are expressing K in the joules, but one is in EV, other one is in joules. Can we use two different units and do it? We cannot. So either you convert this energy into joules or else you convert this K into EV. How do we convert? How do we convert joules to electron volt? What is the conversion factor? Joules to EV, how do we convert? Joules to EV. You need to divide with the charge of the electron. Okay, then you will get it. Right? If you divide your joule with charge of electron, you will get into the EVs. Or else you multiply EV with charge of electron, you get into the joules, anything. Okay. So which one you want to convert, E or K? Anything you can do. So if you want to convert here, they have converted E only into the joules. You convert E into joules. So I cannot directly substitute, that's what I want to say. So before doing that, I have to go back okay, I have to go back and change my conversion factor. This is very important. So I won't substitute, this I will modify like this. How do I modify? As 0.02 into multiply with the charge of the electron, 1.6 into 10 power minus 19, then I will get in. Now whatever you get, you substitute there, I have no problem. So let us substitute there. If I substitute it, I am substituting there. You can use your calculators and substitute first and get me the answer, at least anybody. Let us substitute. F of E is nothing but 1 by 1 plus, what is this value? If I multiply 0.02 with 1.6, 0.03, 2 into 10 power minus 19 joules. So I will substitute there, e to the power 0. E minus EF is nothing but this one, 0.032 into 10 power minus 19 by KT. K is already known, 1.38 into 10 power minus 23 into T is nothing but 200. Yeah, use your calculators, get me the answer. But most of you don't know how to use calculator exponential terms, right? Do you know how to use? Then tell me the answer. First, none of you could do? If you have doubt, please ask me, anybody. Ma? You got 232. And you are not doing, you don't have calculator? Your mobile has, no? Do it, no? 232 you got? Exponentially used, but still f of E is 232. Anybody else? I don't know the answer, whether it is right or wrong. So, okay, I will write whatever you got. 2, how much you got? 232. That much probability it has. So much probability. Probability can be above 1. Can it be above 1? 1 is the top, no? So, okay, work out at your home. Get me the answer. It cannot be more than 1. Simple. Because it is a probability. Go back and check your 0 point.
0015.
That much you got? Okay. He got different 0.2409 you got. Check the facts. Okay. I have not solved it, but you try to do it. Fine, let us go back to next question, then we'll stop Fermi level. One more question we'll do. These answers are, you have to solve your own thing. Huh?
0.59.
That's okay, some point only. Anyway, I don't know which one is correct. We have to check. Let us go back to next question. Next question. Man, probability is 0.24 is correct. That question I have here. 0.24 is correct. Okay. Your answer is wrong. 0.24 was the correct answer. For easy thing, you try to remember k in terms of j and also k in terms of ev. Okay. Note down this. Whatever you want, you can use. K in terms of j first we will write. What is the value? 1.38 into minus 23 j by k, or else in terms of EV it is 8.6. Yes, 8.6 into minus 5, correct, minus 5 EV. 8.6 into EV per k, EV per k. Okay. All the time you need not to do again and again. You can use any of this. But in the exam, we provide the data either this or that. Okay. You need to convert on your thing, or else you remember this. You can use your own. Now let us do one more final question. Let me recue that question is there. It is there, 0 degree and 350 degree. That question is there. In the question bank, is it there? Hey, it should be there, man. Can you see? You can't see. Okay, I will only write. Write down. This is very important. Yeah, an intrinsic semiconductor, an intrinsic semiconductor. Actually, this is uploaded in your semiconductor numericals is there in the Google Classroom. All the numericals you need to solve. One of the numerical is this one. It is okay, an intrinsic semiconductor. Could you see it? It is there. Temperature is 0 and 50 degrees. Read it.
An intrinsic semiconductor
Hmm.
has an energy gap
Hmm.
of 0.5 eV.
Yes.
Calculate the probability of occupying of the lowest level in the conduction band
Hmm.
at 0 and 50 degrees.
Let me write it. An intrinsic semiconductor, this is very important. An intrinsic semiconductor
Has an energy gap 0.4
has the energy gap 0.4 eV. Full stop. Calculate the calculate the probability of occupation or occupying. Occupying the lowest level in conduction band. Can someone explain this? Conduction band at 0 degrees Celsius and 350 degrees 50, yeah? Okay, fine. So that's okay, 50 or 350. Okay, if you are not happy, I will change it to 50 only. 0 and 50 degrees centigrade. Who will write the given data? Given data. What is given? It is slightly tricky to understand. The solution is also provided there. Yes or no? No? Okay, good then. Tell me, with this much efforts, how much you can do? Let me see. What is given? Girls, read first. Point number 1. It is intrinsic semiconductor. There might be some reason why they gave it. Then, what is the energy they are saying? Energy is not given. Interesting. What else they are given? Energy gap is given. Okay. Then, okay, let us write energy gap. Energy gap is nothing but Eg is given as 0.4 eV for an intrinsic level. Calculate the probability of occupation of lowest level in conduction band, which means where are they interested? Always reference is, what is the reference? Fermi energy. EF is your reference. So where is your EF? Where is your EF? Now, because it is intrinsic semiconductor, let us draw the picture for the clarity. So where is your valency band? This is intrinsic, okay. And where is your Fermi level? Between means exactly at the center. This is your Fermi level. Good. Now where are they interested? Probability of occupation at lowest level in conduction band, which means where is it? This one, huh? Which band are they interested? Conduction band only. So where is conduction band? This is conduction band, this is valency band. Conduction band means how many energies are there? How many? It is a band. Band means how many energies? So many are there. All these are energy levels only. That's why we say it is a band. It is not single energy level. So many energies are there. So the starting of conduction band is, where is it starting? This one. Okay. I gave you name for that also. What is that? EC. Why it is starting from there? Now what they are asking, lowest level in conduction. Conduction band has these many energies. Which is the lowest in the conduction band? EC. That's what they clearly giving. Occupying lowest level in conduction band, which means they are interested here. And what is this energy? EV. Highest level of valency band is called EV. Okay. Now what is given? The gap is given. The gap is 0.04. Huh? 0.4 is given. 0.4. So the gap is nothing but in terms of EF, you tell me. In terms of EF, you tell me. EG is nothing but in terms of EF. 2EF, because EF exactly lies at the center. This is EF, this is EF. So gap is nothing but, EG is nothing but 2EF. So EF is nothing but, from here EF is nothing but EG by 2. What is the value? 0.2. And you also know about EF because it is intrinsic semiconductor. EF is nothing but EC plus EV by 2. Because it is intrinsic, it is clear from the diagram. Now use this information. Two cases. Case number 1 is your temperature is, and you need to find what is your F of E. Substitute in the formula. Do you have all the information required? Do you have E minus EF now? Is it there or not? E minus EF is there or not? For the formula you need EF, E minus EF. Do you have E minus EF? That is only EF. What is the formula? 1 by 1 plus e to the power E minus EF by kT. What is E minus EF? All the data is provided. What is E minus EF? E minus EF is 0.2. How? Point 1. How? Diagram is given, required information is given. This is where you need to think. Small tricks only, nothing else. In the formula you need to substitute E minus EF. What you will substitute? Point 2 you want to substitute. Why do you want to substitute point 2? Okay, I will do one thing. I will write the next step. At least you explain me what it is. Okay, let me see that. I will write the step now. This diagram you remember, anyway you know it. So the next step I will write, you try to see the logic, how it came. This is only the toughest problem you have, all other things are very straightforward. So the next step is f of e is nothing but 1 by 1 plus e to the power ef by 2 kt. It is there, I mean eg by 2 kt. It is there in the textbook also. It will be like this only. So I am writing in the same format. Now easy anyway, you know. Now you tell me, this is the next step. How? You understood? How? You explain me. From here it is straightforward, no? Yeah, it was 0.2 only, but how? You understood for yourself at least? Then you explain me also. Video is there, people also will understand. Okay, this I will not upload. No problem. You tell me. For others. Hey, everybody understood? No, right? Thinking. Okay, think. Hera. This you got. How E minus EF is EG by 2. Ma. Hmm. Okay. What is the final answer? I am not explaining more. I am giving time for you to think. Convince yourself. And if your friend is not understood, if they can get convinced, you understood. Otherwise, in the next class, sometime we will discuss about it. But take time to think. Amma. Amma?
Repeat both instead of EG to E
Hmm.
and 2 to
Hmm.
E minus EF is equal to EF.
Okay. Can you explain here? Hmm? Come. That's okay. Come. I want to see all your, you are very good thinkers. I want to see how you think. Uh, huh? Here, this is enough? This much? Okay. There, this side on. Hmm. Right bigger now. Oh, okay, fine. Oh, okay, fine. No problem. That's okay.
E minus EF.
Easy, ra. This was easy, ra.
EG sir.
Ah. Correct only. Nothing. It's okay. Good try. Good. No. This is easy. Hmm. Good try. No problem. No, but you don't know this one. But ultimately, what you get here, according to you, is E minus EF is nothing but TG. That's what you are getting. E minus EF is GG. Okay. So from here, you have to go back. He came from other way, but E minus EF is easy. From this logic, it came. What is the final answer? Let us close this. F of E is nothing but What is the answer that you got? 1 by 1 plus infinity. What is the answer? At 0, what you got? You should be getting at 0 degree centigrade. What did you substitute here? T you substitute as 0. Madam, you substituted T as 0. Convert to Kelvin. 273 Kelvin. Then only you substitute. No infinity will come. If you substitute, your answer f of u should be coming 2 into 10 power minus 4. 2 point something into 10 power minus 4 EV. Get the answer. Similarly, use case number B. If your temperature is 50 degrees, your answer should be, I will give you the answer, you can work out at home. F of E is nothing but, the answer will be 7.5 into 10 power minus 4. 10 power minus 4 EV. Very important. If not in IA final exam, somewhere usually it will appear. Clear? Now let us write 2-3 problems you solve at home. We will close this one. I will write 2-3 problems. Let us solve them at home. So problem number 1, you write it. I won't write it on the board. I will dictate from my book. You can write it. Very simple problems. If you solve them, Fermi level is done. You need not to worry. Find the temperature. Write it. Find the temperature at which, okay, let me write. Find the temperature at which there is 1% probability. At which there is 1% probability that a state with energy, 1% probability that a state with energy 0.5 EV above Fermi level will be occupied. 0.5 EV above Fermi level will be occupied. Can you do it? What you have to find? What is given? What is given, girls? Huh? F of E is given. What is the value? Percent they are given, not the value. What is the value? 1 by 100. 0.01. Okay, what else is given? Temperature is given. What you need to find out? Temperature only you need to find out. Okay. What is given else? E minus EF is given as 0.5 EV. Okay, you can substitute and get temperature. So answer should be, I'll give you the answer. Answer should be 1200, around 1200. 1261.6 kelvins. Around this answer should come. Work out at home. Question number, next question, one more I will write. Simple question again. I think we have done this or not. Find the probability with which an energy level with which an energy level 0.02, same energy is coming everywhere, no, right? 0.02 EV, energy level 0.02 EV below Fermi level will be occupied at temperature two temperatures are there. Temperature number 1 300 K at temperature of two temperatures I am giving 300 K and 1000 K. Somebody tell me given data. Answer I will write, you can verify. For 300 K it should come 0.684 and 1000 K it should be around 0.56. Somebody tell me the given data. EV is given? How EV is given? Below Fermi level. Did they say anything about intrinsic semiconductor or pure or N type? Then don't go to that. First, whatever I explained, no, that you remember. General case. So, what is given? This is key. Energy level below Fermi level is given. If this is your Fermi level EF, you have so many energy levels down, above also so many energy levels are there. Now, where your electron probability, energy level 0.02 below. So, from the reference energy level below there is an energy level, that is from here it is at what distance? So, basically what they are given, you are interested at this point. So, EF minus E is given as 0.02. So, EF minus E is 0.02. So, E minus EF is minus 0.02. That only you have to remember. Then you can substitute. This is the Fermi level is done actually. This much exercise is sufficient even for the final examination. If you are comfortable with that, it is done. All tough questions we already handled. Okay. So, but here definitely one question will be there, either theory or problem, and same for the final examination. It's such an important one. Okay. So, what is the time? Hall effect quickly we can do it or we can stop. Up to you.